Hi guys, welcome to this page of the notes, and what we're going to do here now is begin to look at that objective where, again, we're going to do reflections, but now what we have are some much more common lines of reflection where we are giving you sort of a formula to making that transformation, doing that reflection across the line. So real quick here, let me highlight them for you. These are just sort of real common reflection lines, ones that you'll see much more frequently than others. They're listed for you right here in the table. If we're going to reflect something across the x-axis, this is the transformation that you would apply, right? You're just going to make the y value negative. A reflection across the y-axis, right? Going to flip something across the y-axis, just make the x value negative. Of course, that means if your x is already negative, negative times a negative, you'd be making the x value positive, right? Just whatever value, whatever the sign is of that coordinate already, you're just going to do the negative of it, change the sign of it. A reflection across the line y equals x. The line y equals x is, well, one of the lines that we're going to study as far as kind of like a parent function. It's the identity function, y equals x, because whatever x is equal to, y is also equal to. And you should hopefully recognize, but if not, that graph of the line y equals x is simply a line that splits the first and third quadrant in half, right? So right there and right there, that is the line y equals x, right? Because if x is 1, y is 1, x is 2, y is 2, x is 3, y is 3, right? So we'll split the first and third quadrants in half, right? And so we give you the transformation for reflecting things across that line, which is a pretty common line to reflect things across, and all we do is just switch the x and y value, just switch the spot of those coordinates. And then the last one that is also very common, you'll see quite a bit, is reflecting things across the line y equals negative x. Well, that is just the inverse of the identity function, y equals x being the identity function. What if y were equal to negative x? Well, that's going to be a line, actually here I did this one in red, this one I will do in green. That's going to be a line, again, that splits now the second and fourth quadrant right down the middle. So this guy right here would be that line y, oh sorry, that's an x. Y equals minus x. Okay, and again, the way that you make that transformation is we switch the x and y coordinate, but as you can see here, we make them negative. So these are four of really sort of the most common lines of reflection that we're going to see. And so we'll go ahead and do a couple of these together. Really not too terribly tricky, so we'll jump right into these. Again, please feel free to work ahead on your own, and then just come on back and check your answers here with what we've got. Okay, in the first one, I want you to go ahead, and I've given you the coordinates of a figure. It's going to be a triangle since there's 3 coordinates. Then I want you to reflect that figure across the y-axis. So first, we will draw or graph our pre-image. I'll do that in red. M is at 1, positive 2, so there's my M. N is at 1, 4, so there is my N. P is at 3, 3, 3. 3. There we go. So I have M, N, and P. Now what I'm going to do is I'm going to reflect that image across the y-axis. Let me go ahead and put that line of reflection in there right there. That y-axis is going to be my line of reflection, right? I'm going to get a mirror image of this guy on the other side of the y-axis. Again, what you're doing is almost sort of think of it like this. If you just grab that y-axis and spin it, right? What happens is that guy spins around and shows up on this side. I could even draw a little picture of that, right? We're going to just think of it as sort of spinning that y-axis, right? What is the reflection you would get on the other side? Well, as we said up here in the chart, this is one of our common lines of reflection. Common so much so that we just sort of give you, in general, the way that we make that transformation, reflection across the y-axis. You'll just make the x value negative. So my transformation is going to look like this. I'm going to have x comma y will be transformed to negative x comma y. So let's go ahead and do that in green. M prime will now be at, I make the x value negative, leave y the way it is. So it'll now be a minus 1, 2, minus 1, 2. N prime is now going x value negative, leave the y. So negative 1, 4, negative 1, 4. And P prime is going to be at minus 3, 3. Again, the transformation says make the x value negative, leave the y the same. Go ahead and plot those guys. Negative 1, 1, 2. There's M prime. There's N prime. Negative 3, 3. P prime. And I have my transformation. M prime, N prime, P prime. And I've done a reflection across the y-axis, mirror images of each other on the opposite sides. Again, like I said, I know not terribly tricky. So let's try a couple of more of these together. Please feel free to work ahead. Come on back, check your answers with me. I've got a couple more for you guys right here. Let's just jump right into these. We're going to go ahead and start off by going and graphing our pre-image, which I have given to you. Looks like I have 4 points, so we'll see what this guy turns out to be. Could be a square, could be some sort of parallelogram or something like quadrilateral. We'll find out. 2, 0. Right there, that's going to be D. 2, 2, 2, 2. That's E. 5, 2. Right there. And 5, 1. Okay. All right. So what we wind up with is something that looks like that guy right there. Again, that's going to be D. D. That was E. F. And this point was G. My line of reflection, careful here, y equals x. Like we said, that is our identity function that splits the first and third quadrant in half. So my line of reflection is going to run right through here, right through there, and right through there. And again, the idea is what happens if we just sort of spin that line of reflection, right? What is our image going to look like? Well, here we go. This is interesting. We've actually already talked about this before. Hold up, I'll come to that in just a second. First, what is the transformation? Well, if you go back to that chart on the previous page of the notes, you would see that to reflect things across the line of reflection, y equals x, our little chart says that you switch the x and y values. So it would be y, comma, x. All right, we can go ahead and apply that transformation. Now, before we apply those transformations, now it's time. Please notice that one of my vertices is on the line of reflection, which means its reflection is itself. So that point right there, that vertex E, E and E prime are going to be the same. Let's check and see. D prime, switch the x and y value, so 0, 2. E prime, this is the one that I think, right, is going, its mirror image should be itself. Let's see, it was at 2, 2, switch them, 2, 2, right? Same point, that point right there. Anytime you have a vertex on the line of reflection, its image will be itself, all right? It is its own reflection. F prime is going to be at 2, 5, and G is going to be, that's G prime, is going to be at 1, 5. All right, here we go. Plot our points and draw our image. I already did E. We're going to be at 0, 2, 2 right there. 2, 5, 2, 3, 4, 5, and 1, 5. Right there. There we go. That is going to be, of course, E is E. This was D prime. 1, 5. That is G prime, making that F prime. And hopefully what it looks like is you're just flipping that guy across the line of reflection. Okay, so again, here we go. Just keep going. Not too terribly tricky. Got another one for you here. So we have the line y equals negative x. Hopefully you recall that what that is that is our identity function, which splits the first and third quadrant in half, but because it's y equals negative x, it's the inverse of that. So it'll be the line that splits the second
and fourth quadrant, right down the middle. So right down the middle, right down the middle. And again, we just want to think of what would happen if you would spin that line. I'll graph my pre-image in red. I'm going to be at -4, -2. Right there, that's A. -1, 1. Right there. C, -1, -4, -1. Right there. That's A, B, and C. Now again, we go back to that chart, right? How do we reflect things across this fairly common, this one will show up quite a bit, the inverse of the identity function. And if you go back to that chart on the previous page of the notes, it says the transformation is done by switching the x and y value and negating both of them, making them both negative. So -y minus x. Okay, here we go. We'll apply that transformation, which means then that A prime is going to be at, right, look, I switch them, so it'll be -2, -4, but then I change the sign of each. So A prime is going to be at 2, 4. B prime, they switch places and they both change signs, so now it'll be at 1, 1. C prime, switch places, change the sign on both, 4, 1. Plot your points. 1. That's going to be A prime. B prime is going to be at... Wait, I'm sorry. Sorry. I went to -2. Hold up. There we go. There's A prime. B prime, 1, 1. That puts it right there. C prime puts it right there. C prime, that one's B prime. Draw your triangle, and there is our reflection across that line. Again, if you kind of imagine spinning that line of reflection, you can imagine that being the mirror image across that line of reflection. Okay guys, hopefully that makes a lot of sense. Again, that chart can be very helpful when it comes to common lines of reflection. The y-axis, the x-axis, our identity function that splits the first and third quadrant, and then the inverse of the identity function that splits the second and the fourth quadrant. 4 very common lines of reflection and the transformation that describes each of those reflections. Head on over to the next page of the notes. We'll work on that third and final objective where if I give you the pre-image and the image, can you find me the line of reflection? I'll meet you guys there.